the question that is asked. So here, you can do one thing. See, like let's assume that this 1 volt here, if I apply here 1 volt, let the EMF, let the potential difference here be 1 volt, then you're going to calculate charge. And it will be same charge, what will happen, will flow here, no? I'll take this question. Better rather than, you can think randomly also. No, sir, I'll start from this capacitor. You can do anything. At least what happen, after getting answer, compare the one which is lowest that should be taken. So I'll start with this one. Let this be the 1 volt. If there's a 1 volt, we'll get a charge Q1 minus Q1. The same charge has to flow here, no? Or we'll write capital Q. So what is a, okay, capital Q? This one. What is the Q? Q should be equal to C into V, 3 coulombs. So now we know this charge. Okay, let's check the potential, how much it will be. Potential across this. V2 should be equal to, we'll check this one, Q by 2. Q is how much? 3 by 2. So this is 1.5. So what is V2? 1.5, less than 2 volt. So this is safe. And now how much voltage we applied? 1 volt and 1.5. Then when you apply 1 volt and 1.5, 2.5 volt is what you applied it here. When you apply this 2.5 volt, let's check that what is the drops across these capacitors, V3 and V4. I'll write below. No, V3, 3 into 2.5 by 7 plus 3. 3 by 4 volt. 10, 2.5 will be 3 by 4 volt. Okay, then how much remaining V4 will be? V4 will be 7 into 2.5 by 7 plus 3. Look at V4, is it less than 2 volt? Yes, it is. Look at the V3, is it less than 1 volt? Yes, it is. I think all the capacitors are safe here, no? Now, student, now you have to ask question, sir. How do you can, why you are chosen this one only? Why don't you choose this? Okay, we do one thing. Start from here. Then nothing wrong. You can ask even teacher like this, sir, like why you are chosen that capacitor only? Why don't you choose this? Okay, you do like this one. I think I have to. That verification I'll do by, let me push this to this side. This what our, so what should be our answer? 2.5 volt will be our answer. So next, what student, instead of choosing this one, I'll choose this, you are going to say. I'll continue the question here. And there's a cross check. One problem will be sufficient to analyze. I'm telling this one, only one problem will be sufficient to really learn this topic. So another student, what happen, he will do like this. He will choose this 2 volt here. Then calculate charge. Q minus Q. The capacitance is 2 farad. So what is Q is equal to? Q should be equal to 2 into 2, 4 coulombs. So the same charge should come here. What is the capacitance of this? 3 farad. Then what is the potential drop here? This should be V1. V1 is equal to Q by 3. Q is 4 by 3. So look at the voltage, more than 1 volt, no? So not safe. Okay, now V1 4 by 3 and this is 2. Okay, let's check this one. What is E? E should be equal to now V1 plus 2 volt. 4 by 3 plus 2. 3 2 just 6, 10 by 3. Okay, 10 by 3 volt. Okay, let's check these drops now. 3 farad and this is 7 farad. So V3 is equal to 3 into 10 by 3 by 3 plus 7. 1 volt. So V3 is okay, uh, just safe, you can call that one. So what about V4? Will be 2.3 volt. So not safe, no? This also better say not safe. Okay, got this one. So this is not advisable, no? 3.3 volt open. If you by chance you make 3.3 volt, no, all this 3 will burn out. This is just safe, or at least these two will burn out. Or you do one thing, sir. I'll choose this 1 volt. Means you have to pick up the drop. There's a maximum permitted, no? Make it 1 volt and check that what is the drop across all remaining capacitors. The drop across the remaining capacitor should be less than the maximum rating. Then there is a permitted thing. So using capacitors is a big headache. Huh? So therefore, capacitors all depend. Higher voltage rating is what usually preferred. To minimize calculation, I brought 2 volt, but basically if you go no, it will be 200 volt, 2000 volt, 10,000 volt maximum rating. And the rating depends on what? The type of material. The one which is having more breakdown like a voltage, no? So that particular material is what usually widely preferred for the capacitors.